Okay, so in this lecture, today's lecture, we will discuss that norm is induced by inner product if and only if it satisfies the parallelogram law. So this is the theorem. Let X with this norm be a normal linear space, be a normal linear space satisfying the parallelogram law norm of x plus y whole square plus norm of x minus y whole square is equal to twice norm x square plus norm y square for all x y belongs to x. Then this norm is induced, or you can say they are extended induced by net product this on x such that this holds a net product of x with x is equal to norm x whole square for all x in x. Okay. Proof. So first we assume that x is a real linear space. First we assume that x is a real normal linear space. Okay, x is a real normal linear space. So we have this. We have this is given. Okay, norm of x plus y whole square plus norm of x minus y whole square is equal to twice norm of x square plus norm of y square, name it 1. This is true for all x, y in x. Okay, this is given. So now define this function. Define the function from x cross x to r here, because our scalar field is the real numbers. Y, this it's equal to 1 by 4 times norm of x plus y whole square minus norm of x minus y whole square. Okay, we show that this is an inner product on x. हम प्रूव करेंगे inner product है. So first property, what's the first property of inner product? That's this x is always greater or equal to 0. This is the first property. So we have, let this is true for all x in x. ये आपको प्रूव करना है. So name it 2. Okay, take y equal to x in 2, we get x is equal to 1 by 4 times. This is the norm of twice x whole square, then minus it's a 0. That's equal to, you can easily verify, it's called norm x whole square, which is greater or equal to 0. Also inner product x 0 if and only if norm x square is 0. Since this is a norm here, this is true if and only if x is equal to 0. So that's the first property. Now the second property, the linearity property. Second property, inner product of x plus y with z is equal to inner product of x with z plus inner product of y with z for all x, y, z in x. Okay. So we have by putting y equal to 0. Let's verify first this. Put y equal to 0 in second, we get this. You can see it's equal to, by putting y equal to 0, it's equal to 1 by 4 times norm of x plus y, that's 0, minus norm of x minus y, it's again x. So this is equal to 0. That's inner product of x with 0 is 0 for all x in x. Okay. Now to prove this part, हमें जो प्रॉब्लम आई थी वहाँ पर जो 1/2 हमें बाहर निकालना, तो उसी को हम पहले देखेंगे वो हम कैसे निकालेंगे. So we first verify that we first verify that this thing we verify twice inner product x plus y over 2 with z is equal to inner product x with z plus inner product y with z. So if you take y equal to 0 in this equation, then it will give twice inner product of x by 2 with z is equal to this x with inner product of x with z. Since y is equal to 0, this part will be 0. तो वही तो हम एक्चुअली कर रहे थे, 1/2 को बाहर निकाल रहे हैं, जो यहाँ पर हम कल फंसे थे ना, कल के लेक्चर में. तो इस y by 1/2 को एक्चुअली बाहर निकालना है, तो ये वो हमें इससे मिलेगा. तो अगर हम इसको कर पाएंगे, अगर हम y का वैल्यू 0 देंगे, इट विल बी ट्वाइस इनर प्रोडक्ट ऑफ x by 2y is equal to inner product x z plus inner product 0 z is 0, जो हमने ऊपर वेरीफाई कर ही दिया है. तो यहाँ पर आप इसको लिख सकते हो सिमिलरली ना, दिस इनर प्रोडक्ट ऑफ 0 विथ x इक्वल टू 0. अगर आप इसको यहाँ पर चेक लिखना चाहोगे, क्योंकि हम वही पार्ट यूज़ करें. सिमिलरली इनर प्रोडक्ट ऑफ 0 विद y is equal to 0 for all y in x. Okay, ये भी 0 के बराबर है. So let's first verify this. This is true for all x, y in x. Okay. So we start with this. Okay, we start with this. So we have twice inner product x plus y over 2 with z. Now by our definition, this is the inner product of x with any element is 1/4 times, so it's already twice, so it will be 1/2 times. By our definition, norm of sum minus norm of the difference. So norm of sum means x plus y by 2 minus z whole square minus norm of difference. Norm of sum is here, x plus y over 2 minus z whole square. So I want to apply that identity parallelogram law. Okay, I want to apply parallelogram law here. So how do I do that? For this I need norm of x, twice norm of x square plus norm of y square. So I want here some plus, I want to norm x plus y over 2 plus z whole square plus some norm of some vector whole square. Okay, then I will subtract the same number. So I choose that number suitably here. It's equal to 1/2. It's equal to 1/2 norm x plus y by 2 plus z whole square plus, so that number which I am choosing here, it's x minus y by 2. Okay, x minus y by 2. So that if I can, then I am adding these two. this x plus y by 2 plus x minus y by 2, it will be x. So this the 2 in the denominator, so it will go. So if I choose this number here, x minus y divided by 2 whole square. So it's like this, it's norm of this square plus norm of this square. We know that twice norm of x square plus y square is equal to norm of x plus y whole square plus norm of x minus y whole. That's this. वही तो actually आपकी ये identity है जो आप use कर रहे हो ना. But we are going to use this identity actually. That's here. Okay. This you want to use. So twice. Get this, twice norm of x square plus norm of y square is equal to norm of x plus y whole square plus norm of x minus y whole square. So in that case, in our case, we have instead of x, we have here x plus y divided by 2 plus z, and instead of y, we have x minus y by 2. So now if you add these two things, so you will see that it will be x plus y plus z like that. So let's apply this identity. It's actually here 1, you can see 1 is the identity that we are going to apply. Okay, this is equal to, okay, अब आपने प्लस इसको कर दिया, यही नंबर आपको माइनस करना है. Okay, this number, let's write it like this, then minus times, we have this now, x norm, it's norm, sorry, x plus y over 2 minus z whole square, then plus norm of x minus y by 2 whole square. Okay, now these two will go. Okay, norm of x minus 2 by whole square, this is here, minus norm of x minus y divided by 2 whole square, these two will go. So it's okay now. Okay, so but for that I must have twice, okay, to apply the to apply that identity here, parallelogram law. So I will multiplying and dividing by 2 here, it's 1 over 4 times twice, okay, twice norm of x plus y divided by 2 plus, sorry, it's a whole norm is here, it's not, it's norm of,
sir,
yeah,
ये ऊपर वाला स्टेप जरा रिपीट करो.
Okay.
प्लीज सर.
I will explain it. Okay, so so actually you see the first previous page, this, so we had to find out this actually. So actually मैंने एक step यहाँ skip कर दिया, that's why it creates problem. Oh yeah, I have skipped one step here. No, it's okay. So by definition, what's definition? इनर प्रोडक्ट ऑफ x जो आपने डिफाइन किया, आपने इसको ऐसे डिफाइन किया, मैं ऊपर लिख देता हूँ, ठीक है, आपको क्लियर करने के लिए. इट्स इक्वल टू 1/4 norm of x plus y whole square plus norm of x minus y whole square. तो इस तरह से आपने इसको डिफाइन किया. अब यहाँ पर जब आप यहाँ से 2y होगा तो 2 यहाँ पर भी मल्टीपल होगा, इट विल बी 1/2 दिया. इज इट ओके? तो 2y x y इज इक्वल टू 1/2 टाइम्स दिस.
यस सर.
तो यहाँ पर वही है 2y, x की जगह पर यहाँ पर x प्लस वाई डिवाइडेड बाई 2 और y की जगह पर z है. सो इट विल बी देयर सम माइनस देयर डिफरेंस. इज इट ओके? अब हमने क्या किया, मैंने बस यही किया कि मैंने ये ऐड किया x माइनस नॉर्म, दिस वन जो नेक्स्ट स्टेप है ना, फर्स्ट ये तो इट्स ओके, इट्स मैंने सिर्फ नॉर्म ऑफ x माइनस वाई बाई 2 होल स्क्वायर इसको ऐड किया, फिर यहाँ पर इसको सब्ट्रैक्ट भी किया बिकॉज इट्स माइनस टाइम्स हियर, यू कैन सी.
ओके सर.
Okay, so but now I have to apply the this parallelogram law. So I must have twice norm of x square plus norm of y whole square, वो मुझे मिलना चाहिए. So what I will do, I will dividing and multiplying by 2. So it will be then 1/4 times twice this plus norm of x minus y divided by 2 whole square. ठीक है, प्लस ट्वाइस नॉर्म ऑफ x plus y divided by 2 minus z whole square plus norm of x minus y divided by 2 whole square. Okay. Oh, it's set minus here. It's a minus sign here. This is minus here. This is minus. Not so clear?
Yes, sir.
Okay.
Yes, sir.
So look at this. It's like this: twice norm of x square plus norm of y square. Here it's again twice norm of x square plus norm of y square. So instead of x we have x plus y by 2 plus z, and instead of y we have x minus y by 2. और सेकंड केस में x की जगह पर क्या है, x प्लस वाई बाई टू माइनस जेड, और y की जगह पर क्या है, x माइनस वाई बाई टू. So you apply this identity 1, that parallelogram law. This you have to apply this one, जो ना 1 जो आपने नाम दिया है, इसको अप्लाई कीजिए. Twice norm of x whole square plus norm of y square is equal to norm of the sum plus norm of difference. इसको आप अप्लाई कीजिए. Let's apply this. So it's equal to, then it's equal to 1 by 4 times. So norm of sum. So let's see the vectors first. So first vector is x plus y by 2 plus z. Second vector is x minus y by 2. So their sum. Okay. It's norm of the sum x plus y by 2 plus z and x minus y by 2. X plus y by 2 plus z plus x minus y by 2. Okay. Norm of x plus y whole square plus norm of x minus y. X की जगह पर फिर से ये x plus y by 2 plus that this your x, then minus y. Y is here x minus y by 2. Minus. Now second part. What's the second part? Second part is x. What's x here? X is here x plus y by 2 minus z, and y is here x minus y by 2. Y is same, but x is x plus y by 2 minus z, not plus z here. So it's equal to norm of x plus y divided by 2 minus z plus x minus y by 2 whole square. Okay, plus norm of x plus y by 2 minus z and minus x minus y by 2 norm whole square. And this is equal to 1 by 4 times. This is by 1. Okay, by 1. 1 by 4 times. Now look at this. It's plus y by 2 and minus y by 2 here. They will go. Then it's plus x by 2 plus x by 2, that's equal to x. So it's x plus y plus z. It's norm of x plus, no, not x plus y plus z, it's just x plus z. Y तो खत्म होगा ना, y by 2 minus y by 2, x plus z whole square. Plus here it is minus plus, it will be minus x by 2 plus x by 2, they will go, and there remain y by 2. Yeah, it's y plus z. Okay, it's x y plus z. Y plus z whole square, right? Minus times. Now here minus y by 2 plus y by 2, they will go. It's x minus z. Norm of x minus z whole square. Good. It is now here. Sorry. Then it will be x minus z. Okay, x minus z. So here it will be y minus z. Okay. So that's equal to that 1 by 4 times this. It's actually inner product of x with z, and this one is this plus sign or minus sign here. What's this? It's a minus sign actually here. So these two will go. should be plus sign. It should be plus sign. Is there any problem? It should be plus sign. We want plus sign here. I want plus sign here. I want plus sign, not a minus sign. Is there? Is it okay? So both are minus actually. So this is inner product x with z plus. Okay, so I have to actually I should write this here. Sorry, I have to change this words actually. This is equal to 1 by 4 times, it's okay, it's norm of x plus z whole square, then minus norm of x minus z whole. That's the inner product actually. Okay, these two minus, okay, plus norm of y plus z whole square minus norm of y minus z whole square. Now it's okay. And this is equal to inner product x with z and plus this inner product y with z, because you know that inner product 4 times x with z, 4 times inner product x with z is equal to norm of the sum minus norm of the difference of these two. That's here, norm of sum, norm of difference. Okay, again here it's norm of sum of these y and z's and norm of the difference. So that's so therefore we have this. 2y's inner product x plus y over 2 with z is equal to inner product x with z plus inner product y with z. So putting y equal to 0 here, putting y equal to 0, we get 2y's inner product x by 2 with z is equal to inner product x with z plus inner product 0 with z, that's equal to inner product x with z. So or you can say this 1 by 2 times this. Okay, this is true for each x. Okay, for all x and z in x, this works. Okay. So in particular, if I replace this x with x plus y by 2, so name it third. This is true for each x. So replacing x by x plus y by 2 in third, we get this 2y's inner product x plus y by 2 with z. Okay, this x को मैंने रिप्लेस किया x plus y by 2 से, और यहाँ पर भी x को रिप्लेस करेंगे x plus y by 2. Okay, x plus y divided by 2 set. No, x को रिप्लेस करेंगे x plus y से, सॉरी, just x plus y divided 2 तो है ही वहाँ. Okay, so this will be 2y's x plus y divided by 2, और यहाँ पर होगा x plus y with z. So this is equal to, okay. Now this implies, but this you have seen, this is equal to inner product x with z plus inner product y with z. That's equal to inner product x plus y with z. ये आपने अभी चेक किया ना, ये वाला. तो मैं इसका कुछ नाम रख दूंगा. So इसका नाम है स्टार रखूँगा, ओके, by star, okay. So that's the linearity in the first variable. Linearity in first variable. So so that proves linearity in the first variable, okay. So next we verify that. Now हम डायरेक्ट प्रॉपर्टी यहाँ पर लिख देंगे जो हमें प्रूव करनी है. That's the scalar, okay. It's symmetric, okay. That's very simple. Inner product x y is same as inner product y x for all x y and x. So this is an assignment for you. This is very simple, okay. The fourth property, which is very important, that's this: inner product alpha x with y is equal to alpha times inner product x y for all alpha belongs to R and x y belongs to x. So this is if alpha is a positive integer, then it's done, because if alpha is a positive integer, see, or you can say non-negative integer. If alpha is a non-negative integer, not a positive, non-negative, it may be 0. It's a non-negative integer, say n, then inner product nx with y, it's equal to inner product nx means x plus x plus x. अगर n 0 होगा तो उस टाइम में n into 0 0 के बराबर होगा. inner product 0 y is 0, and on this side it's n times inner product x y, that's 0 times x y, which is again 0. तो उस केस में आपको कुछ नहीं करना है. So this is it. This is n is greater or equal to 1 here. So that's equal to, you can apply the property, because inner product of x plus y with z is x z and y z, so you can repeatedly apply that property. It will be inner product x y plus inner product x y plus inner product x y by second, जो अपनी by second property यहाँ पर, it's not by second equation, okay. Second property जो आपने भी check की, that's equal to n times inner product x y. So if n is 0, then there is nothing to prove. Then this nx with y, it's equal to 0 with y, because n is 0, that's equal to 0, and n times inner product x y, it's 0 times inner product x y, that's also equal to 0. So उस केस में भी हम n को बाहर निकाल सकते हैं. अब अगर n नेगेटिव इंटीजर होगा, उस केस में आप क्या करोगे? तो नेगेटिव के लिए सबसे पहले आप कोशिश करो कि माइनस साइन को कैसे बाहर निकालेंगे, ओके. सो नेक्स्ट वी वेरीफाई दैट. नेक्स्ट वी वेरीफाई दैट दिस इनर प्रोडक्ट minus x with y is equal to minus times inner product of x with y, okay, for all x y and x. We have inner product 0 with y, this inner product x minus x with y, and that's equal to inner product this is x plus minus x, okay, x plus minus x. मैं इसको यहाँ पर लिख दूंगा x plus minus x, इससे आपको पूरा क्लियर होगा. We are actually applying the additive property, not the difference property. It's inner product x with y plus inner product minus x with y, and on this side it's 0, this is 0, okay. So this means that inner product minus x y is minus times inner product x y. So from this so therefore from this we can prove that it's true for every positive, every integer. So therefore if alpha is any integer, then this holds. alpha x y is alpha times x if it's an integer. अब आप प्रूव करेंगे रैशनल्स के लिए. सो नाउ if alpha is equal to p by q is a rational number, is a rational number, then we have rational के लिए प्रूव करना, we have this inner product px with y. Okay, this is equal to inner product q times p by qx with y. So this implies, यहाँ से मैं p को बाहर निकाल सकता because p is an integer, it's a rational number, that means p and q are integers. This is equal to, यहाँ से मैं q को बाहर निकाल सकता हूँ. अब q को यहाँ ट्रांसफर भी, q is a non-zero number. Okay, so that means inner product alpha x y is equal to alpha times inner product x y. Alpha is a rational number. So rationals के लिए भी आपने इसको प्रूव किया है, rational number को भी हम बाहर निकाल सकते हैं. Now suppose alpha is any real number. Finally, if alpha is a real number, so for this real number I can choose a sequence of rationals which converges to x. So choose the sequence, because the rationals are dense, choose the sequence Rn of rationals such that Rn converges to alpha. Now let's see this inner product alpha x y. Here alpha is now any real number. By definition, what is this inner product? It's 1 by 4 times norm of alpha x plus y. अभी मैं क्योंकि inner product it's not inner product, अगर inner product होता I can apply the continuity property. So but I cannot apply that because this is not stated an inner product. So but this is a norm. So norm is continuous. Okay, I can apply continuity property of norm here. Minus norm of alpha x minus y, square here. Okay, this is equal to 1 by 4 times norm. What's alpha? Alpha is limit of Rn. Okay, the limit of Rn, then we have x plus y whole square minus, this is a limit of Rn x minus y whole square. Okay, now इस लिमिट को हम बाहर निकाल सकते हैं नॉर्म से, because norm is continuous. This is limit of norm Rn x plus y whole square minus limit of Rn, the norm of, सॉरी Rn को बाहर नहीं निकाल सकते अभी, Rn को भी अंदर ही रखना है. So this is okay, this is limit, limit को बाहर निकाल सकते नॉर्म से. It's Rn then x minus y whole square, and this is a scalar multiple. Scalar multiple is also a continuous function, so limit को scalar multiple से बाहर निकाल सकते हैं दोनों लिमिट्स को. This is equal to limit n approach to infinity 1 by 4 times, okay, norm of Rn x plus y whole square minus norm of Rn x minus y whole square. अब Rn को भी बाहर नहीं निकाल सकते. This is limit n approach to infinity 1 by 4, but this is actually the inner product Rn x with y. Okay, अब यहाँ से इसको बाहर निकाल सकते हैं Rn को, because the Rn is a rational number. So this is equal to limit n approach to infinity, और n को बाहर निकाल सकते हैं 1 by 4 times inner product x with y. Okay, it's now it's not 1 by 4 here. Okay, हमने इस प्रॉपर्टी को अप्लाई किया है, जब हम इनर प्रोडक्ट लाएंगे then there is no 1 by 4, so this is not 1 by 4 here, just this. So what's this limit of r? It's alpha times inner product xy. So that proves the inner product properties of this. Okay, all the properties. Symmetry property हमने चेक की है, और स्केलर मल्टीप्लिकेशन लीनियरिटी ये भी हमने चेक किया. So thus this is an inner product on x, and what is this? X with x, you can see it's equal to norm of x whole square for all x in x. ओके, सो कॉम्प्लेक्स केस आप खुद करोगे. कॉम्प्लेक्स के केस में आपके पास क्या होगा? वहाँ पर सिर्फ आपके पास इसका जो इमेजिनरी पार्ट होगा 4 टाइम्स एक्स वाई इसके बराबर होगा. उसके प्रूफ सिमिलर है. वहाँ पर आपके पास है नॉर्म ऑफ एक्स प्लस वाई होल स्क्वायर माइनस नॉर्म ऑफ एक्स माइनस वाई होल स्क्वायर. ओके, प्लस आयोटा टाइम्स है नॉर्म ऑफ एक्स प्लस आयोटा वाई होल स्क्वायर माइनस नॉर्म ऑफ एक्स माइनस आयोटा वाई होल स्क्वायर. तो ये पार्ट इसमें एक्स्ट्रा है. आप ऐसे डिफाइन करोगे इसको 4xy को, तो वहाँ पर प्रूफ इज सिमिलर. सो if x is a complex nonlinear space, the proof is similar. The proof is we define this function by that equation. Okay, it's 4 times actually norm of x plus y whole square minus norm of x minus y whole square plus iota norm of x plus iota y whole square minus iota norm of x minus iota y. Okay, norm of x minus iota y, norm of x minus iota y whole square. Okay, for all x y belongs to x, we define this. So then this function, then this is inner product on x. Okay, inner product on x. The proof is similar as the proof is similar as in real case, okay. This proof is very similar. Now we define Hilbert space. Okay, Hilbert space. An inner product space H is said to be an Hilbert space. And हम Hilbert space के लिए फिक्स नोटेशन करेंगे H है. An inner product space H is said to be a Hilbert space. उसको हम कहेंगे क्या? Hilbert space. If the normal unit space by the norm is induced by that this inner product, if that normal unit space is complete. So if it's complete, if it is complete, if it's complete with respect to the norm, induced by the inner product, इनर प्रोडक्ट। मतलब H आपके पास इनर प्रोडक्ट स्पेस है, इस पर इनर प्रोडक्ट ये है। अगर ये H कंप्लीट होगा विथ रिस्पेक्ट टू दिस नॉर्म, अगर आप इस पर ये नॉर्म डिफाइन करोगे, विथ रिस्पेक्ट टू दिस नॉर्म इट्स अ नॉर्मल लिनियर स्पेस। अगर ये नॉर्मल लिनियर स्पेस कंप्लीट होगा विथ रिस्पेक्ट टू दिस नॉर्म, दैट दिस इनर प्रोडक्ट स्पेस विल बी कॉल्ड हिल्बर्ट स्पेस। ओके, so in other words we call it a complete inner product space. Okay, complete inner product space or Hilbert space. So we have some examples of Hilbert space. The first example is तो नॉर्मल लीनियर स्पेस कब हिल्बर्ट स्पेस होगा, जब वो पैरेललोग्राम लॉ सेटिस्फाई करेगा। तो अगर आपके पास कोई भी बनाक स्पेस होगा, उस पर जो नॉर्म होगा उसने अगर पैरेललोग्राम लॉ को सेटिस्फाई किया, इसका मतलब है कि वो इनर प्रोडक्ट स्पेस होगा। तो कंप्लीट भी है, बनाक है और प्लस इनर प्रोडक्ट स्पेस, देन इट विल बी अ हिल्बर्ट स्पेस। सो लेट्स टेक फर्स्ट एग्जांपल, लेट H is equal to Kn. Okay, Kn means set of n tuples of scalars, set of n tuples of scalars. Okay, so for let's define the inner product on this Kn. For x equal to xi, I runs from 1 to n tuple. Okay, y is equal to yi, runs from 1 to n. In this H we define this function xy is equal to summation I runs from 1 to n xi and yi conjugate. You check the inner product properties, then ये आपने लीनियर अलजेब्रा में किया होगा, then this is an inner product on H, and if I and this अगर हम नॉर्म ऐसे लीजिए वहाँ पर, what's that norm? Norm is inner product of x with x. What's that? That's xi conjugate, which is mod of xi square. Its square root. This is actually inner product x with x power 1 by 2, which is equal to summation I runs from 1 to n xi square power 1 by 2, power 1 by 2. This is a norm. Clearly it's a norm, it has already verified. And this, that we know that with respect to this norm, this H is complete. It's either Rn or C. It's complete with respect to, it's called the Euclidean norm. We know that H is complete with respect to the norm. So let's name it 1, norm 1. So therefore H is a Hilbert space, because this norm is induced by the inner product actually. Therefore H is a Hilbert space. H is a Hilbert space. इस पर आप बहुत सारे नॉर्म्स को डिफाइन कर सकते हैं ना, क्या, क्योंकि आपने इन जनरल आपने नेक्स्ट एग्जांपल अगर आप लोगे, लेट H is equal to LPN. Okay, LPN. So this H is an inner product space. So LPN means this set up again n tuples xi runs from 1 to n, such that these xi's, they are in scalar field K, where here the norm is defined by norm xp is equal to summation I runs from 1 to n mod of xi power p whole power 1 by p. Okay, we'll see that for p equal to 2, this is induced by inner product for p equal to 2, for p equal to 2, norm, this norm, pth norm is induced by inner product, inner product, because it satisfies the parallelogram law. For p equal to 2, it can be easily verified. We show that if p is not equal to 2, then this norm is not induced by inner product. It's not induced by, that means we cannot define any inner product on that edge, such that, so instead of h I should write here x, because it's not so for p equal to 2 I denote it by h, okay, because for p equal to 2 it's a Hilbert space. So for p not equal to 2, I will show that this norm is not induced by inner product. Means that I cannot define any inner product on x such that inner product x is equal to norm p whole square, norm p x whole square, okay. So that's not true. So suppose it's true, suppose it is induced by some norm, then it must satisfy the parallelogram law. So for if it is induced by some inner product, because inner product satisfies the parallelogram law, then it must satisfy this norm of x plus y whole square plus norm of x minus y whole square is equal to 2y norm x square plus norm y square for all xy belongs to, it's pth norm, okay, pth norm here, for all xy belongs to this L P N, okay. तो ये होना चाहिए, but if we take this x equal to this tuple and y equal to this tuple, okay, and tuple, okay, then let's calculate this first and then we calculate this. We will see that both are different actually. Then norm of x plus y p square plus norm of x minus y p square, you calculate this norm, you have already defined it, and you will see that this is equal to 2 power 1 plus 1 by p, okay. And on the other hand, to y is norm x p square plus norm y p square is equal to 4. You can see this is equal to 4, and you see since p is not, for p equal to, for it should be here 2 by p, not 1 by p, okay, it's 2 by p, it's 2 by p, you can verify it's 2 divided by p, 2 power 1 plus 2 by p, and for p equal to 2 these two are equal, okay, but for p not equal to 2 then these two are not equal. So clearly 2 power 1 plus 1 by p is not equal to 4 for p not equal to 2. So therefore norm x plus y whole square plus norm x minus y whole square is not equal to twice norm x square plus norm y square, it's pth norm here, it's fixed norm, this is not equal to this for p not equal to 2. So hence this norm is not induced by inner product, induced by inner product for p not equal to 2. For p equal to 2 it is induced by inner product. So there are other examples like we have LP spaces. LP,
वहाँ पर ना
yeah,
2 raised power 1 plus 2 by p clearly.
2 raised power, oh yeah, it's 2 by p here, yeah, it's 2 by p. तो इसको आप कैलकुलेट करोगे, आप इसको कैलकुलेट कर पाओगे दिस नॉर्म जो मैंने यहाँ पर आपको रखा. It's very simple. X is fixed, and x plus y it will be 1 comma 1 then 0 0 0, and this will be what, 1 then minus 1 then 0 0 0. Now you calculate this norm square, you will see that it's 1 square plus 1 square plus 0 square plus 0 square whole power 1 by p. Okay, then on this side it's 1 square plus 1 square plus 1 square whole power 1 by p, whole power 1 by p. Okay, 1 power p, sorry, 1 power p plus 1 power p, not this whole power 1 by p. So let's calculate this norm, huh? Let's calculate this norm. Okay, let's see this norm x plus y whole square plus norm x minus y whole square p. So this is x is 1 0 0 0, then y is 0 1 0 0 0. So you can add component wise, it's 1 1 then 0 0. Okay, pth norm square, and here it's x minus y. X is 1 0 0 0, y is 0 minus 0 1 1 0 1 0 0 0. So it will be 1 minus 1 0 0 p square. So what's the pth norm? Pth norm is you have to add these numbers, then it's square of that, it's whole power 1 by p, and we have a square, it will be whole power 2 by p there. So it's 1 power p, in fact it's mod here, 1 power p plus 0 power p plus 0 power p whole power 1 by p, then it's whole square. Okay, क्योंकि नॉर्म पर आपके पास स्क्वायर है. So it's x1 power p, x mod of x1 power p plus mod of x2 power p plus so on plus mod of xn power p whole power 1 by p plus again we have here mod, so mod of 1 mod of minus 1 is 1, so it's again 1 power p plus 1 power p plus 0 power p plus 0 power p, it's whole power 1 by p, then whole square. Okay. So this is clearly 2 power 2 by p. Okay, plus this is clearly 2 power 2 by p. So these are same powers, so this will be twice. Okay, twice 2 power this, so it's 2 power 1 plus 2 by p.
बताएगा minus 1 power p.
It's actually mod, क्योंकि ये जो एक्चुअली जो
mod
जो आप नॉर्म डिफाइन करते हैं ना, नॉर्म
वो mod पे होता है.
हाँ या नॉर्म इज ऑन मॉड. सो इट्स एक्चुअली लाइक दिस, mod of x1 प्लस mod of x2, अब pth है तो p होगा यहाँ पर. ओके, प्लस mod of x होल पावर 1 by p है.
ओके सर.
तो क्लियर. सो आज हम इसमें इतना ही करेंगे. इसके बाद कुछ और एग्जांपल्स देखेंगे हम इनर प्रोडक्ट स्पेस, हिल्बर्ट स्पेसेस की. लेट्स एंड इट हियर.
सर क्या हर कोई हिल्बर्ट स्पेस बनाक स्पेस हो सकती है? एंड
हाँ, एवरी हिल्बर्ट स्पेस इज बनाक स्पेस, या एवरी हिल्बर्ट स्पेस, क्योंकि वहाँ जो नॉर्म इंड्यूस होगा ना, उससे वो नॉर्मल लीनियर स्पेस बनेगा. आप क्योंकि वो विद रिस्पेक्ट टू दैट वो कंप्लीट होता है, इट्स अ बनाक स्पेस. वही तो डेफिनेशन है हिल्बर्ट स्पेस की. हिल्बर्ट स्पेस की वही डेफिनेशन एक्चुअली, जो भी हिल्बर्ट स्पेस होगा वो बनाक स्पेस होगा. कन्वर्स इज नॉट ट्रू. बनाक स्पेस नीड नॉट बी हिल्बर्ट स्पेस. लाइक जैसे आपके पास है ना, एवरी फाइनाइट डायमेंशनल स्पेस इज बनाक स्पेस, है ना. यहाँ पर ये जो फाइनाइट, यहाँ पर आपने एलपीएन लिया ना, इट्स अ फाइनाइट डायमेंशनल स्पेस, सेट ऑफ एन टॉपल्स, but it's not induced by inner product, that it's not inner product space. ये तो inner product space ही नहीं, तो Hilbert space कैसे होगा? तो Hilbert space के लिए पहले कंडीशन है कि it should be inner product space. So this is an example. हाँ, तो ये एग्जाम्पल है. अगर आप इसको नोट करना चाहोगे, इस एग्जाम्पल को, LPN is Banach space. Banach space, but not Hilbert space. For p not equal to 2. So for p equal to 2, it is both. For p equal to 2, for p equal to 2, this is here L2n, okay?
Yes, sir.
Is both Hilbert and Banach. Is Hilbert space. Simple. Is Hilbert, every Hilbert is Banach. Is Hilbert space. Okay.